Hello again, our most valued student. My name is Confident and welcome to AgroLearn Text 24-minute lesson. Our lesson today is going to focus on a new topic on trigonometry. This is the first lesson on trigonometry. In this lesson, we're going to introduce the reduction rules. We are also going to look at the trigonometry equations as well as special angles. Let us look at the first part when we mean by the reduction rules. When we're talking about the reduction rules, there is a special diagram that I want to introduce to you. It is called the cast diagram. Now, when you are given this kind of a diagram, if you still remember, this is the y, this is the x, but this is a Cartesian plane. In this Cartesian plane, these are the few things that I always want you to remember. Now, we refer to this as quadrant number 1. This one is quadrant number 2. This is quadrant number 3. And this is quadrant number 4. It is named anticlockwise. Now, in quadrant number 1, remember it is less than 90 degrees. This is 90 degrees. So we write it as 90 minus theta, because it is less than 90 degrees. In quadrant 2, because we are above 90 degrees but less than 180, remember this is 0 degrees. If I can use another pen, this is 0 degrees, this is 90 degrees, this is 180 degrees, this is 270 degrees, as well as this is 360 degrees. We call it a 1 revolution. So now, when we are in quadrant number 2, you will notice that we are after 90 degrees, but at the same time we are less than 180, hence is 180 minus, we are after 90 degrees, you write it in 2, 90 plus theta, because we are after 90 degrees, but we are less than 180 degrees, is 180 minus theta. A very important quadrant that I always want you to remember. This one. The next one is we are after, in quadrant number 3, we are after 180. So we write it as 180 plus theta. And in quadrant number 4, we are after 270 but less than 360. And we write it as 360 minus theta. If you notice, we never involved 270. So don't involve 270. Now, with this particular diagram having been labeled like this, there is something that we call cast diagram. I'll use another pen. This is how you write the cast diagram. The C is written here, the A is written here, the S is written here, and the T is written here. What does cast diagram mean? For you to remember it quickly, A means all students take chemistry. Take chemistry. That's how you can remember the cast diagram. All students take chemistry. All students take chemistry. All students take chemistry. All students take chemistry. So this is the special cast diagram, and this diagram is very, very important for remembering the reduction rules. Now, what does this cast diagram mean when you say all students take chemistry? By all, we are saying here sine is positive, cos is positive, tan is positive. All of them are positive in the first quadrant. By saying S for students, it only means sine is positive, cos is negative, tan is negative. Only sine is positive. In quadrant number 3, for T, it means tan is positive, cos is negative, and sine is negative. And in chemistry, we mean cos is positive, sine is negative, and tan is negative. So the best way to remember is using this cast diagram. What do we mean by saying it's negative. If you punch any angle that is in quadrant A, that is less than 90, you'll discover that you're going to get all the positive values. For example, let us test this particular diagram. So now when you look at this cast diagram again, I have redrawn again the cast diagram, and I just chose angles at random. For example, sine 55, you'll discover, don't worry about the number that you'll get, look at the sign before. Use your calculator to punch sine 55, you are going to get a positive. Cos 55 will also be a positive, and tan 55 will be a positive. You go to the quadrant number 2. In this quadrant number 2 here, we are saying, this is 1. In quadrant number 2 here, you just choose any angle that is above 90 but less than 180. Sine 120, you will find sine is positive, but you find cos will be negative and tan will be negative. Choose in quadrant number 3, choose any angle that is above 180 but less than 270. Remember, this is 180. Now you are going to discover that sine will be negative, cos will be negative, only tan will be positive there. You come here, look for an angle that is above 270 but less than 360. I just chose 315. Sine will be negative, cos will be positive, and tan will be negative. This is what we mean by the cast diagram. This is very important. We are going to be using this diagram in most of our work. You need to understand it. Again, to summarize, remember, in quadrant number 1, it's 90 minus theta. Don't forget that. In quadrant number 2, we have got 2 of them. It's after 90 but less than 180. It's 90 plus theta because we are after 90 degrees. We are after 90 degrees, but 180 minus theta because we are before 90 degrees. In quadrant number 3, we are after 180 degrees but less than 270 degrees, which is 180 plus theta, but don't involve 270. We don't put it in our reduction rules or in our cast diagram. After that, that's why we've got 180 plus theta. The last one, we are after 270, but we are less than 360, which is 360 minus theta. Now, when you have done that, as I said, just test it. You'll see that it gives you the signs that we have done according to the cast diagram. Here we are saying all are positive, as you saw. All of them positive. Here only sine is positive, here only tan is positive, and here only cos is positive. Now let us look at simple trigonometric equations as a start. If you are given sine x is equal to 0.5, they want to find x, so this is how you do it. You say x is equal to arc sine, this is how you write arc sine, and then you put 0.5. When you use your calculator to punch arc sine 0.5, you are going to get an angle of 30 degrees. So the answer is 30 degrees. That's how you solve it. There is another one. They are using sec x. Now what is sec x? To remind you again, remember, sec x is equal to 1 over cos x. Cosec x is equal to 1 over sine x, and cot x is equal to 1 over tan x. These you must always remember. Sec x is 1 over cos, cosec x is 1 over sine, cot is 1 over tan. So now if they gave us sec x is equal to 0.31, what we need to do now is to remember sec x is 1 over cos, and then we say 1 over cos x is equal to 0.31. What we do is we also equate this to over 1 and we cross multiply. Remember the cross multiplying. When you cross multiply, you are going to have 0.31 cos x is equal to 1 times 1, which is a 1. You divide both sides by 0.31, divide both sides by 0.31. When you do that, what you're going to have is cos x is equal to, if you say 1 divided by 0.31, which is equal to 3.223. Now x is equal to arc cos 3.23, and this answer will be undefined. Hence, it does not exist. It's undefined because you cannot find a cos of a number that is greater than 1. But this is the way you're supposed to approach it. Let us move on. It says simplify 2tan theta minus 30 degrees is equal to minus 1,5. Now what do you do first? Number one, the first thing to do is to divide both sides by a 2. So you divide both sides by this 2. Why are you dividing by 2? So that you're going to have now your tan theta minus 30 degrees is equal to, if you divide that negative 1,5 and you divide it by 2, you are going to get negative 0.75. Now when you have done that again, what you must remember is to now remain with this inside the bracket. We do the same thing like we did when it was a single thing. When it was a single, we said, let me just show you a bit. When it is single, let's say they said tan theta is equal to 2. How do you find theta? You say theta is equal to arc tan 2. You understand? You say arc tan 2, or theta, whatever is inside here is arc tan 2. So I can actually put brackets like this and say theta is equal to arc tan 2. Or I can let my theta here become theta minus 30. It's inside the brackets. If this is now inside the bracket, it will be still theta minus 30 is equal to arc tan 2. Hence here, what is inside the bracket? You are going to say theta minus 30 degrees is equal to arc tan negative 0.75. You pretend this was a single thing, theta minus 30, just like you had as a single theta. When you have done that, is theta minus 30 degrees is equal to, when you punch arc tan 0.75, you're going to get minus 36.87 degrees. So what is theta? Theta then becomes minus 36.87. You take 30 degrees to join the other side of the equal sign, you to become plus 30. Then your answer is going to be negative 6.87. So that's how you solve that particular problem. The next problem that we are given here is, if I look at this one, it says 3 sine x cos x plus, let me work it from here, 3 sine x cos x plus cos x equal to 0. How do you solve that? The first thing is to see something common there. You have got cos and cos common, and you can factorize that cos. So if you factorize cos x, what are you going to have? You're going to have 3 sine x plus 1 equal to 0. When you have done that, it means, just like in any particular given equation, for example, let me work it from this side. If they say x, 3x plus 1 equal to 0, you're going to say x is equal to 0 or 3x plus 1 equal to 0. Then you solve for x. The same thing you do with cos. You're going to say here cos x is equal to 0 or 3 sine x plus 1 equal to 0. How do you find x? In the first one, x is equal to arc cos 0. And what is arc cos 0? If you find arc cos 0, it will give you 90 degrees. So theta is called 90 degrees, or you divide both sides by 3 like previously. Before you divide, actually, you take 3 sine x is equal to, you take the 1 to jump the equal sign, you're going to have minus 1. You divide both sides by 3. After dividing both sides by 3, then you're going to find arc sine x is equal to arc sine minus 1 over 3. Then you're going to get, if you do arc sine negative 1 over 3, we are going to get minus 19.47 degrees. So these are the two values of theta. Either theta is equal to 90 degrees or theta is equal to minus 19.7 degrees. Let us move on. They are saying we are given sine squared x is equal to 0.5. Now solve for x. They want us to solve for x where they are giving us a range. Look at the range now. 0 is less than or equal to x. X is less than or equal to 360 degrees. This is very, very important. This is very important for you to look at the range that they have given you. In other words, they are saying the value of theta must be between 0 and 360. If you still remember our cast diagram, it was from 0 to 360. So now when you are solving it, what you need to do now, if we continue to solve it, now if I take that, remember it's sine squared x is equal to 0.5, but remember there is a squared. Now, how do you write that squared? If I can write it in a proper way, this is how you write it. If it's a squared, you say sine x. Let me put it in a clear version. You say sine x squared is the same as 0.5. Then you square root both sides like usual, and then you're going to have sine x is equal to, then you find the square root of 0.5, which is square root of 0.5. You can leave it from simplifying. Then you're going to say x. Therefore, x is equal to arc sine square root of 0.5. When you have done that, you are going to say, what is x? Arc sine square root of 0.5. If you use your calculator, you are going to get 0.01. That's, sorry, I think I did punch my calculator wrong. Arc sine square root of 0.5. Actually, I did punch it wrong. It is equal to 40. With my calculator, I'm getting 45 degrees. But they gave us a condition. They are saying use, it must be in the range 0 and 360. And if you remember our cast diagram, there are two places where sine is positive. It is in quadrant 1 and in quadrant what? In quadrant 2. And in quadrant 2, the 45 degrees is in quadrant 1. What about in quadrant 2? Remember, quadrant 2 was 90 plus theta. So the other answer is 90 plus 45, which is equal to, you are going to get 135. So the two answers there is either x is equal to 45 degrees. Look for another side where x is positive. It is x is equal to 135 degrees. Let us look at the next one. 10b is equal to 2.6. 10 2 beta is equal to 2.6, and the range is still the same. It's 2.6, where 0 is less than or equal to theta, theta is less than or equal to 360 degrees. So what you do, you same thing, you say 2b, you always write what is inside there. Last time it was a bracket, but now we just say 2b is equal to arc 10 2.6. Now 2 beta is equal to, you say arctan 2.6, and you're going to get an angle of 68.96 degrees. Then you divide both sides by 2 to get your final angle, and your beta is equal to, when you divide by 2, you're going to get 34.48 degrees. Now remember, this is not the only answer. You go now to your cast diagram. Remember, all students take chemistry, and you find a place where 10 is positive. 34.4 will be here, and there is another place where 10 is positive in quadrant number 3. So what is quadrant number 3? It's 180 plus theta. So in this case, another value of beta is equal to 180 plus 34.48, and then we are going to get a value of 214.48. So here beta is equal to that, or beta is equal to 214.48. These are the two values of theta. Again, the next one says find cot theta is equal to 2. They're giving us a range. Again, remember, if they say cot theta is equal to a 2, you know what is cot. Cot is 1 over 10 theta. 1 over 10 theta is equal to a 2, and then remember it's over 1. You cross multiply. When you cross multiply here, you are going to get 210 theta is equal to 1. You divide both sides by 2, and you're going to have 10 theta is equal to a half. And then after that, you've got theta is equal to arctan half. And you follow the same method that you did previously. Because of time, I'm not going to do it. Now, the other one that is interesting is this one. Sine 2 alpha minus pi over 2 is equal to 0.5. What you do again is the same thing. You say sine 2 alpha minus pi over 2 is equal to 0.5. Now what you must remember is pi is equal to 180 degrees. So this is same as sine 2 alpha minus 180 over 2 is equal to 0.5. The next step is the same like what we did. This is same as sine 2 alpha, 180 over 2 is minus 90 degrees is equal to 0.5. What you do now, you say 2 alpha minus 90 is equal to, remember, arc sine 0.5. And you work it like we did in the previous one, where you find arc sine 0.5. It will tell you that is 30 degrees. So you're going to have 2 alpha is equal to 30 degrees plus 90. And then when you do that, you are going to find now the two values of alpha as we did before. Now, we're going to end then our lesson at this moment. If I can finish it up, it is going to be, in this case, remember it's 2 alpha is equal to, it's 30 plus 90, 30 plus 90, 2 alpha is equal to 120 degrees, but I divide both sides by 2, so I'm going to have my alpha is equal to 60 degrees. After I've done that, I go to my cast diagram. In my cast diagram, remember all students take chemistry. I look at a point where sine is positive because I was dealing with sine, and sine is positive in the first and second quadrant. So the first one, 60 is going to be here, and in this one, it's 90 plus theta, which is 90 plus 60. What is 90 plus 60? You're going to get 150. So alpha is equal to 150. Someone will say, but we're writing here also as 180 minus theta is still the same. You can say, or another version is 180 minus 60. So if we use 180 minus theta, is going to be, in this case, you are going to get sine as theta is equal to 120.